In this lecture, we are going to discuss how to forecast with a time series model. Now, of course, you might say, I already know how to do this. I just call model.predict. But that is not the answer because you don't actually know what's going on when you call that function. The purpose of this lecture is to actually expose a common mistake, although obviously if you ever want to implement your own forecasting model from scratch, these ideas will be helpful. Okay, so recall that one way to think of an autoregressive model is that it's just linear regression. You can implement an autoregressive model yourself, provided that you organize your data in the correct way. Let's recall what that is. Suppose that we have a time series, y1 up to y10. Also suppose that we want to build an AR3 model, so p equals 3, which means the number of columns in our dataset is 3. Therefore, we organize our data into tables as follows. The first row is y1, y2, and y3. The corresponding target is y4. The second row is y2, y3, and y4. The corresponding target is y5. Alright, so you get the idea. Now at this point in the course, we're a little more sophisticated than we were before. We know that, in addition to the training data, we want to have test data so that we can be sure that our model actually predicts the future. So let's say we would like the last 3 samples to be the test data. Alright, so we call the first 4 rows the training data, xtrain and ytrain. Then we call the last 3 rows the test data, xtest and ytest. What's next? Then we fit our model. So we instantiate a linear regression object. Then we call model.fit xtrain ytrain. Then we can calculate the out-of-sample accuracy of our model by calling model.score xtest ytest. We can also make future predictions using model.predict xtest. Unfortunately, this is all wrong. I repeat, do not do this. So this is something I alluded to earlier in my lecture on the naive forecast. In that lecture, I said that one of the bad things marketers do is they write these articles about predicting stock prices with LSTMs that make this huge mistake. Well, this lecture is all about what that huge mistake is. As you've seen for yourself after going through this section, it's very easy to get a plot where the model predictions almost exactly track the true value. How can this be when stock prices are so hard to predict? Well, the reality is, these models are doing nothing but making a prediction very close to the naive forecast. In other words, these models are basically just copying the last value. They're not learning the underlying pattern. The reason they look so close is because these plots typically contain so many data points that you don't get to see them up close. But how do these marketers get their plots to look so good on the train set and the test set? As you know, the model should never see data from the test set, and therefore should have no opportunity to copy those values. Well, in fact, that's exactly where the mistake is. If we split up our data more carefully, what we would want to do is this. Let's suppose again that the last 3 data points are for the test set. These are the data points that we want to forecast. So that's y8, y9, and y10. y1 up to y7 belong to the train set. Well then, what's the problem with defining our xtrain and our xtest matrices as we did before? Well, as you can see, we are making a mistake by including true test values as inputs into the model. This is not allowed. To see why this is more clearly, let's look at how we would actually compute a forecast. Suppose that today is day 7. We are trying to make a forecast for day 8, day 9, and day 10. Since today is day 7, we can only use y1 up to y7 to make predictions. So for example, if today is July 7, then obviously we can't use the values on July 8, July 9, or July 10 because those days haven't happened yet. Okay, so that should be fine. We can calculate y8 in the usual way. Y hat 8 is equal to b plus phi 1 times y7 plus phi 2 times y6 plus phi 3 times y5. That makes sense. Next, we have to calculate y hat 9. Now you just follow the pattern. So you might say y hat 9 is equal to b plus phi 1 times y 8 plus phi 2 times y 7 plus phi 3 times y 6. Unfortunately, this is all wrong. Remember, we do not know y 8. The best thing we can do is plug in y hat 8, our prediction for day 8. So in actuality, y hat 9 is equal to b plus phi 1 times y hat 8 plus phi 2 times y 7 plus phi 3 times y 6. We can repeat the same pattern for y hat 10, which will depend on y hat 9 and y hat 8, and the true value on day 7, y 7. So just in case this isn't clear, let's summarize what's happening in pretty much all of these blog posts and even some paid courses that I've seen claim to show you how to predict stock prices with LSTMs. First, they make the mistake of not splitting up the data properly. That is, they include test data as inputs into the forecast period. This isn't necessarily wrong if you make it clear that you are only trying to predict one day ahead. I've never seen anyone make this admission. 2. By doing this, all they've done is created a model that copies the previous value in a time series, or very close to it. You've already seen in this course that this basically leads to the predictions being very close to the true time series. As long as you're zoomed out far enough, they're basically indistinguishable. And 3. To bring this back to the naive forecast. Generally, this would be okay if you make it clear that you are only trying to predict one day ahead, and you check that your forecast is better than the naive forecast. Obviously, this must be done on the out-of-sample data or the test set. These models will not beat the naive forecast. Note that this is obvious when you consider the API for stats models. As you recall, it works something like this. First, you create an ARIMA model. When you call the ARIMA constructor, you pass in the training data. Then you call model.fit, which takes in no arguments. Later, when you want to get your in-sample predictions, you call result.predict. The arguments to this are only the start and end indices, not any data. If you want to forecast, you call result.forecast. Note that the only arguments to this function is the number of forecasting steps. Therefore, there is no point at which your model ever sees any data points from the test data. Your model only sees the training data, which is passed in when you instantiate the model. So what is the lesson here? The lesson is that whenever you see plots like these, pay special attention to the actual code. Are these models actually predicting stock prices? Or are they just finding very computationally expensive ways to copy the last value in a time series, most likely performing worse than the naive forecast? Furthermore, we know that it's not stock prices that we care to predict, but rather stock returns. If you've had experience with machine learning, then you know it's probably not a good idea to use prices as inputs or outputs to your model. Machine learning models are generally not good at extrapolation. So for example, if the prices that you trained on were between $100 and $200, then maybe it'll learn something for that range of prices. But what about in the future, when your price goes beyond $200? Your model has never seen this before, and therefore, it probably won't know what to do. So be suspicious when you see marketing material like this, and don't use test data in your forecast.